In this video, we're going to be looking at circle theorems and the things that you need to be able to do with circle theorems in order to access those very high level questions. So your first task is to recognize essentially the pictures of each of the circle theorems. There's 6 of them, and so you have to be able to recognize each of them individually, and then when you come to the GCSE exams, they usually combine 2 or maybe 3 together. Okay, so let's take a look at some of these circle theorems. The most common ones would probably be the arrowhead. Okay, I'm not going to use their proper names just for now, but more like a sort of description of their shape. So if you have an arrowhead and the middle is in the center of the circle, then whatever this angle is here is going to be 2 times this angle. Okay, so this is one of the common circle theorems, and before we sort of go through all of them, I just want to mention as well an exam technique that's really useful is that they will say in the exam this is not to scale, and this might be something like 60 degrees, and they want you to work out this one. When you do this in the exam, you could actually measure this angle. It won't be 60, but it'll be close. It might be 55 or 65 or something like that. And if you measure this one, you will see that it'll be exactly half, because even though it's not to scale, it's still a circle, so it still obeys all of these rules. So bear that in mind. You can measure them and help you to see exactly what's going on. Okay, and I just want to mention as well that they often will do something like this with the arrowhead, is that they might move it kind of down here. Whoops, let's grab this, there we go, and put that kind of here. And this shape looks very much like the next one that I'm about to show you. But the difference is this is in the center as opposed to being on the circle's circumference. What do I mean by that? If we look at this one here, where you have the similar sort of shape, the bow tie shape, okay, you can see that all 4 corners are on the circumference of the circle, whereas this one of the corners is in the center. So that is something to be aware of. This would still be 30 degrees here, as opposed to the bow tie one, which is where the corners are exactly the same. So those corners are the same, and these corners are the same. So 30 degrees here would make that 30, and if this was 25, that would be 25. They're not the same as each other, but they're the same as this sort of opposite corners. Okay, so we've got the arrowhead, we've got the bow tie shape, we've got the diameter. If that goes through the center of the circle, then we can connect that to anywhere else and make a triangle like this. Or you could go kind of down here. As long as you make a triangle where the 3 corners are on the circumference and the diameter is in play, then that will always make a right angle. Okay, and this one is a tricky one because it opens up so many higher level concepts later on. You can have Pythagoras in here, trigonometry, perpendicular lines and things like that. So this is definitely one that you need to be aware of. The diameter creates this right angle. Okay, another one that we have is when you have a 4-sided shape, kind of like this, any 4-sided shape, and all corners are on the circumference, but it doesn't cross over in the middle like the bow tie one, so there's no crossover. When that happens, if you look at the opposite corners, they add up to 180 degrees. This corner and this corner will also add up to 180 degrees. Okay, Four-sided shapes always have 360 in, but for a circle theorem, the opposite corners have an added property. They add up to 180 degrees. Okay, the last two involve tangents. Okay, so I'm just going to put a tangent to the circle. A tangent just sort of brushes past the outside of the circle like that. And for this circle theorem, another very, very common one is that if I connect the tangent to the center, that will make a right angle as well. So just like the diameter one, this can open up many, many high-level topics, coordinate geometry, Pythagoras, trigonometry, all of those sorts of things can be contained within this one circle theorem. So this is quite an important one, tangent to the center. The last one is probably the least understood by students. The way that we recognize this one is that it doesn't go to the center. Okay, so the one that goes to the center is the most common, with the tangent making the right angle. But if it doesn't go to the center, we have this last one, which is a little bit strange, coupled with the fact that they often don't provide this connecting line here. Okay, that dotted line there often isn't present, and you have to know to connect those together. When you do that, this angle and this angle will be the same, and then this angle and this angle will be the same. Okay, so quite a tricky one there at the end, but we recognize it by seeing a tangent, and if it doesn't go to the center, then it will be this kind of triangular shaped one that we have to be able to sort of build up and recognize where the similarities are. Okay, so what I would recommend at first is that you draw the circle theorems on a flashcard without the detail about where the angles are and what can be created. Okay, so you might just have the bow tie without the red and the blue indicators of where the angles are the same. When you turn it over, you can add those in, and that will help you to spot where the angles are the same, the opposite corners, the right angle being created. You just start with that. Okay. Then, as you progress, you will have to describe the name of each of these at the very highest level. Just like you did with angle facts, when you had a straight line and that was 60, and they said, what is this angle? And you say, oh, it's 120 because they add up to 180. And then they say, give a reason for your answer. And you have to say, angles on a straight line add up to 180 degrees. Well, we have to do the exact same thing with the circle theorem. So as you've got to the stage where you've actually recognized each of these individually, then you can add to the back of your flashcard, where it's got the answers to the angles, their name underneath. Okay, so you can't go into the exam and say bow tie, arrowhead or whatever. You have to come up with their actual names. So you can check your notes from school, you can check online if you're not too sure. Very quickly, we have a cyclic quadrilateral, so opposite corners of a cyclic quadrilateral add up to 180. Angles in the same segment is the bow tie. Angles in alternate segment for this one down the bottom right. The angle subtended by the diameter and the circumference is a right angle for this one. And the arrowhead is angles at a point, a half angles at the center, or you can have it the other way around, angles at the center, a double angles at the circumference, angles at the point here. This one with the tangent to the center will create a right angle. You can just kind of say that one for this one. So you would need to learn those, try to sort of recite them parrot fashion as best you can. And then when you really recognize each of these individually, not necessarily with the names, you'll be able to put two of these together. So you might have the bow tie one and the cyclic quadrilateral all in one, kind of like this. And so you would be expected to kind of recognize that there are two circle theorems in there. Okay, so it's stages for this one. Try to learn the individual ones, then try to put them together, and if you can, the cherry on the top, learn their names as well.